A VPN and a proxy are two pieces of tech that each has their own applications, differences, and pros and cons. Both make requests on behalf of the client, but they are implemented very, very differently. In this video, I want to go through the following. I want to talk about how VPN works. I'm going to show you some diagrams, how exactly it works. We're going to talk about what is the pros and cons of using a VPN. And then we're going to jump into our proxy and talk about how a proxy works. Again, guys, we made a lot of videos about proxies in this channel, but I didn't make a lot of videos about VPNs. That's why I wanted to make a difference between these two, right? And then finally, we're going to talk about the pros and cons of using a proxy, right? Regardless of what you are using it. And finally, we're going to summarize the whole thing. If you're new here, welcome. My name is Hussein. In this channel, we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing and hit that bell icon so you get notified every time I upload a new video. With that said, let's just jump into this video. So, before we jump into how VPN works, let's explore how just normal networking setup looks like, right? You have a beautiful router here. There is a public IP address for your router. There is a private IP address on another interface, obviously. And then this is also your DHCP, so it gives you beautiful IP addresses. So this is you like 14, 112, 192.168.102. So that's a network. That's a completely different network with another public IP address, another private IP, and there's like a bunch of other machines, right, inside that. So that's essentially a completely two networks that are independent of each other. So what happens if I am this guy, I want to make a request to google.com, a GET request, so that's an HTTP request. What does that mean? What happens? Well, you make a request to google.com, you find out the IP address, and then if you find out the IP address, it says, oh, it's not in my subnet, so router take care of it, and the router will essentially forward the packet on your behalf to google.com server, right? So that goes like that essentially. I'm very much simplifying it here. I'm glossing a lot of stuff here, but that's essentially what's happened. You go through the internet. This is the internet, by the way. I just found a picture of a cloud and put it there, right? So you go there, and the Google essentially knows your IP address, not this one. Obviously, it doesn't know the private IP address. It knows this. Right, it knows the 44123, which is your router, your private router, or if you're in a coffee shop, it knows that not that location, and from that IP address, they can find which city you are. You can pretty much find a lot of information about you. Okay, and that is essentially doing a NAT, network address translation, to translate your IP address to the public IP address, and the router keeps track of it. And we talked about NAT, guys. I'm gonna reference the video here if you're interested about that. So yeah, you make a request, goes there, and you can make other requests, not only HTTP, right? Like ping, right? You can ping this machine 192.168.1.3, which happens to be in the same network that you are in, and that goes in the same network. You don't have to go to the internet for that. Okay. Similarly, if you want to access something that you're not supposed to access, it doesn't exist, like 10.0.0.4, right? This is a completely different network, and you're here, right? Tough luck. You cannot access that. This is a completely different network. It's a private set of IP addresses that you're not supposed to access. It's just not there. So you're gonna know. So let's talk about a VPN. What is a VPN and how it works, okay? So a VPN essentially makes you, if you decided to be a part of a VPN, what happens is this literally makes you part of a private network. So let's assume this guy is a VPN server, because guess what? It's always a client server connection, right? So this is a VPN server. That's what I want to communicate to. That's your NordVPN. That's your ExpressVPN. That's your any VPN service out there, or you can host your own VPN server if you want to, like your work VPN, right? And that's the VPN client. That's the client that wants to be part of a network. So what happens here is it uses certain protocols, and here's few of them, like the layer 2 tunneling protocol, IPsec, and the key exchange version 2 of the thing. So you can use any of these protocols to establish this VPN, right? And what does that mean, right? Once you do that, once you establish a VPN, which is a complicated logic at the lowest level, right? It's a layer 2 protocol. Okay, and we talked about OSI, guys, and how's these levels different. I'm gonna reference the videos here. So this essentially plays at the MAC address level and the frames, right? So it's very, very, very low level. And once this session or tunnel is established, guess what? You are now part of that network. And how does that work? You establish essentially an encryption if that protocol supports encryption, right? And then you start encrypting any packets between you and that server, right? So that's the tunnel. And we also talked about tunneling in this channel. And I'm going to reference the videos in the description, the tunneling videos. But what happens here is you become part of that network. So any network request, and I mean anything, becomes part of that network. So that means if you want to access 10.0.0.3, you can do that. That's normal, right? Because guess what? Let's go through the ping now. I'm pinging 10.0.0.3, which is this machine. I am now 192.168.1.4, and I've been assigned this IP as if I am this guy, okay? So if I want to ping, I package that request. It is encrypted now because I am part of the session, and I sent it to my router. And my router doesn't really know that I'm pinging 10.0.0.3. It says, it only sees that, yo, router, I'm making a request to this public IP address. Just forward it, please, and shut up. Okay, that's what it knows, right? And it requests that. It's an encrypted packet. Your router cannot look at it, obviously. And it reaches here, and that guy, because there's a protocol, it unpacks that encrypted packet, decrypts it, and looks at it and says, oh, you want this guy want to ping 10.0.0.3? Sure, let me ping it, and just pings that and gives you the results. That's simple, right? So because it was encapsulated, right? Let's go through a get google.com example, right? Same thing, right? Encapsulate the packet, send it to the server. Yo, server, take me to 66678. Send that packet and shut up. That's what it does. Say, okay, I'm going to take that, and there is a NAT, obviously, that converts this to the 10.0.0.2, and then that receives the packet, encapsulate it, open it, decrypt it, looks at, oh, you want to make a GET request to google.com? Sure, let me make a GET request to that. So Google here knows that this guy made a request. Well, it knows that this guy made a request, but you get the idea, right? So you kind of become quote-unquote anonymous. I disagree with that a little bit, the word anonymous. We're going to talk about the cons there. But yeah, so you're encrypted, you make a request. That sounds good, cool, right, guys? So that's how a VPN works. That's essentially how a VPN works. Anything this includes pings, web traffic, database connection. If you're here and you want to access a database that is listening on port, I don't know, 5432 on this IP address, you can. That's how. If I'm on my work, I VPN to a machine that is on my work, right? And that machine essentially gives me access to entire work private network, and I can do pretty much access any machine. Obviously, it's going to be very slow, right? Because of all the communication. We're going to talk about that. But yes, you can have access to anything, file system, file shares, all of that protocols. You can do them because they are at the lowest and the lowest and the lowest level, because layer 2, right? If they are built on the higher levels, you couldn't have done that. Okay, so that's essentially what VPN. All right, here's what I'm not sure about. I'm not sure that the new client will get a brand new IP address as a result of a DHCP call to the host router from the VPN, or will the VPN server assign its IP address to the client? Probably the former, but I'm not sure because I have a lot of questions I couldn't find answers for though. So for any of you who know the answer, please write it in the comment section below, right? Especially for you network engineers out there who knows this answer, I will appreciate if someone can clarify that point exactly from an IP address point of view, right? So that will be amazing. Let's go through the pros and cons, right? Pros, by default, it encrypts all the traffic, which is pretty good, right? That's pretty good. So if you're browsing a naked website like HTTP, it's not secure, well, the VPN will actually encrypt that for you, because guess what? It's encrypted at the lowest level. There is a session, so nobody sniffing in the internet can actually know what you're doing. Well, except if they sniff at the other side, they can, because that's not encrypted. But yeah, so essentially they don't know who you are, right? But that encryption is happening. That's good, right? It redirects all traffic at the lowest level, and that's a layer 2, right? So at the MAC address frames session there, that is where all the action is happening, right? So it's very transparent, right? There's a bunch of frames that are encrypted. Nobody knows where they are. You know they're going to that destination, and that's it, right? So, and that's an advantage, because now you can actually redirect all traffic, regardless what that are. File shares, you can access restricted websites, right? You can access any restricted website. If they are restricted, your IP address is banned for any reason, well, you can access that VPN, and that VPN public address is not restricted, so that will make the request on your behalf. So that's why people like use VPN to watch Netflix shows that essentially are banned in certain or are not allowed in certain countries, right? And the reason is because of this. They just access a completely network, and nobody knows. Netflix does not know you, right? They don't know who made the request. They know that this network is making a lot of requests. They might know that this is a VPN, right? And it's not hard to block it. But yeah, so that's how it's happening essentially. Access private networks at work, like, yeah, if I want to work from home, I can VPN to my work computer, and then from work computer I have access to pretty much everything as if I am at work. That is incredibly slow, though. Let's talk about the cons. Well, there is anonymity for VPN. Well, I added meh, because to be truly anonymous, that means nobody can actually know who you are. Well, in VPN, they actually know who you are, right? The VPN company knows you. They know your IP address because you make the request, you establish a session with them, right? So they know you, right? And so that's not really completely anonymous. You might argue that, hey, VPN, when I signed the contract with the VPN, they said that they agreed to not log any of my data, and they don't know you. But you can, it's just your word against them, right? You don't know, but they do know you essentially. So that's anonymity. I don't know about that. Very slow because of this extra hops. There's always one extra hop to the VPN. The VPN makes the request on your behalf, because you're essentially another machine that makes a request on your behalf. That adds slowness. That's why when I connect to my work, it's always slow, because there's always multiple hops instead of single hop. And if your application is chatty, tough luck, because let's say your database application makes, I don't know, 10 requests per second, right? Double that, because if you're using a VPN, you just double it, right? Or maybe triple it, depends on how many hops between you and the VPN, because a lot of NATing is going on, obviously, between switches and routers and stuff, right? So that's essentially slows things down, right? And the chattier the application, the slowest it gets, right? That's why essentially HTTP applications is better, because they are request response, and developers are very aware of, oh, I'm making one request and I get a response. So you pack as much as possible in one request. Sorry about that. I know I'm going all over the place, but essentially this is useful information, I think. Double encryption. Yes. So 99.99999% of the websites out there, guys, guess what? They are encrypted. They're using HTTPS. They're using TLS, right? Most protocols use TLS, which is Transport Layer Security, and we talked about that. I'm going to reference it here. So what that means is you are essentially having an end-to-end encryption between you and the destination server anyway. Add to that the encryption of the VPN, and you just slows things then double unnecessarily, really, right? Because the TLS is hard to break as it is, and add another encryption is just talk about just paranoia right there, right? It's just paranoid. I don't think people will actually be able to decrypt that stuff, because just the VPN is encryption, and the other TLS encryption is just there, just right. And if you know how TLS works, and we talked about hops, TLS is, at least the 1.2 version, uses like I think 2 round trips, which is like 4 requests, right? 2 requests going on, 2 responses. So that double that times 2, because of VPN, right? That slows things down. And then encryption, the symmetric key decryption, right? That actually slows things down even more than that, right? So slows it becomes really, really slow to use a VPN, right? And VPN can't log your data. Well, let's pause there. VPN can log your data, right? If they can see it, right? They can log pings because they are unencrypted. They can log DNS requests, right? It's like, hey, I want to go to youtube.com or google.com or I don't know, the whitehouse.org, right? Is it org? I don't know. .gov, right? So they know these are plain text requests. So they know that you, Hussein, is making a request to see this page. That's it. They cannot see if you're going to Google and searching for how to lose weight. They cannot see that. Google uses HTTPS all the time for every single request, right? That means there's a TLS, end-to-end encryption. So the VPN cannot see what's going on, right? But they can see where did you go, and they can look the information. This is valuable, and I talked about how what VPN actually can see. I'm gonna reference the video here, right? And obviously, it doesn't provide any caching. And better not, right? Because if the VPN is caching your stuff, that means they can look at your stuff, right? But we're going to talk about how proxies actually benefit from caching. Sorry about the voice, guys. This is me, Hussein, after editing. As I was editing this video, I noticed that I missed one important point as well. So we talked about how VPN makes you part of a private network, right? So essentially, they make you part of a network, and that network, now you're part of it. You're assigned an IP address of that subnet. What does that mean? Mean that you have access to resources in that network. What it also means that those computers have access to you. That's shady stuff, because if you are not sure what VPN server are you connecting to, and you have your machine is sharing some resources, right, to certain, I don't know, you shared it in your machine, you thought it's like, hey, I want to share it for everyone, for example, but you're in your own network, so you're trusting your own network. But the moment you connect to a VPN and you said you share it for everyone, guess what? If there are people of this VPN server is shady, that network can access your stuff that you have shared, obviously not everything, but just the fact that you know that you're part of a network, so you better know what network are you connecting to, right? So that's why you have to, if you decided to use a VPN, know what VPN are using. If you're paying for good stuff, yeah, they're gonna isolate you in a VPN that is basically just you. Yes, because I'm not sure what will happen. I don't have expertise in that area, but just think of it logically, right? Because I access my work VPN, right? And the moment I do that, I log in as my username. But what does it mean when I access a VPN that is just a public VPN? That's a weird name for it. But yeah, what does it really mean to access a VPN, right? You're part of a pool of a network. I hope that network is just dedicated for me. I If you have other people in the same network, which I think VPN companies do that, obviously they want to pool as much people as possible, and they will isolate you from each other, probably. But it's just something to think about, right? I'm not 100% sure what's going on there, but just keep it in mind that this is scary stuff. Proxies! We talked a lot about proxies, guys, in this channel. We're using them. We built proxies from scratch. We use them as load balancers. We don't think of a proxy as just this thing that you connect to connect to somewhere else, right? This is just one small piece of the proxy, right? But it's used a lot of applications. So let's talk about what is a proxy and how it works. So that's you, that's a machine, that's a network, this is the internet, and that's a proxy server. It's listening on port 7, no, this is the IP address, and listening to port, I don't know, 8080 maybe, right? 77111. What happens here is when you configure your machine, you say, hey, my HTTP proxy, and there are, yes, many types of proxies. The HTTP proxy is this guy. And when you say that, your packets are always destined to the proxy. This is the final destination from a layer 4 perspective. That's the IP address. You always destine your packets to this IP address, 7111. And then you send the packet, right? And then you might say, Hussein, like, if this is the final destination, how does the proxy know what is my true final destination, which is Google, for example? Well, let's go ahead and get an example. And I want to go to google.com. And listen here, I specifically said HTTP, which Google doesn't support, but let's assume for the sake of example, they do support HTTP, plain HTTP, unencrypted, right? If you say that, you say a GET request, google.com, give me an index.html. What happened here is you send the request to the proxy. And the IP address, the destination of the IP address is actually 7111. The router looks that you're connecting to this proxy. And that's it. Well, I'm saying that's not enough. How does the proxy know how to make a request to Google? Well, that's why in HTTP 1.1, version 1.1, they added a header called host. And the host says clearly that google.com, I want to connect to google.com. In HTTP 1.0, that header didn't exist. So we couldn't do proxies in HTTP 1.0 back in the 90s, early 90s. There's no proxies. You couldn't do them because we said, right, this is the final destination. Well, I'm tough luck. I don't know where you're going, right? But if you specify the header, now the proxy will look at your data, and emphasis on the look. They can see where you're going. They can see everything. They see your search requests, they see your terms, they see the nasty thing you're searching on Google. They see everything because it's HTTP, because it's unencrypted. They see it, right? And they make a request on your behalf. And then you give you back the results. So that's how a proxy works. It makes a request on your behalf, but it's a very application specific. That means if I try to ping google.com, tough luck. We're not going through your proxy because that's a different protocol. That's a lower level protocol. I don't know. I think it's a layer 3 protocol ping, right? So we're going to ping and we're not using the proxy. That's not a proxy request, right? So we'll go through the internet and just shove it into google.com. So Google will know you in this case. In the previous case, Google doesn't know you. I'm adding because they can know you. There's methods to do that. I'm going to talk about that. But yeah, so make it a ping request. It goes directly Google, right? What if I go to the secure side of Google, HTTPS, and I have a HTTP proxy? Guess what? We're not going to the proxy because that's a different protocol. It's a very protocol specific, the proxy things, right? And application can bypass it, can dance around it whenever they want. All right, so you can bypass this thing, right? Let's talk about the pros and cons of proxy, right? It can cache, that's a good thing. if you're going to http://husseinnasser.com and you downloaded my blog through a proxy, the proxy will say, yeah, okay, I download. I'm going to keep a copy here for the next person who requested husseinnasser.com. So if you requested it again, it says, I'm not going to go to the google.com. Here's a copy. It's a little bit old. Maybe it's a 1 minute old, but sure. Here it is. I don't think something changed on the server, so you think you're good. Take this copy. Very fast stuff. Caching is good, right? Okay, but guess what? If you're caching, the proxies can see your stuff. If you're okay with it, that's okay. But if you're not, then probably you want to bring the proxy to a private location where you actually trust it, right? So think about that. It works both at a layer 7 and a layer 4 perspective. So a layer 7 because it's an application layer, right? Because it's HTTP is an example. It looks at the data, it can do stuff with it because it understands the context. Also, there are proxies that works at the layer 4 perspective, like a transparent proxy, like a firewall proxy, and like a HA proxy, the load balancer, right? It sometimes works at the layer 4 perspective context. And when you do that, you have only access to very small things like the port, the IP address, and that's pretty much it. You cannot see any data. You cannot trust the packets, right? Because they might be encrypted. But so proxies can work at both these layers, and that's it. They cannot go any lower than that. That's what she said. Anonymity, meh, right? So don't use proxies if you really want to be anonymous, because proxies, again, HTTP proxy, right? They can see your data. That's the first thing, right? Even HTTPS proxy can see your data. It's actually more dangerous, right? If you're using a public HTTP proxy, it's not really anonymous, because most proxies add via headers and other forwarded from and forwarded to headers. They change the content of the headers to tell the final destination where this request came from. So don't use it for anonymity, because it's not going to be anonymous, because the final destination, Google, will find out who you are really, because the proxies will start adding the via. Especially there's a chain of proxies, a proxy to another proxy talking to another proxy. They add stuff to the headers, like via headers. And there's like vias, like, IP address 1, IP address 2, IP address 3. So you can see like the chain of the request up until the final destination. Okay, so none of them, none of the VPN nor proxies provide anonymity. You want to be anonymous? Go to Tor, right? That thing is actually encrypting you left and right and doesn't know who you are. Well, the CIA runs a bunch of Tor nodes, but that's out of the question, right? But yeah, so if you want to truly be anonymous, use Tor, because that nobody actually knows who you are except the CIA. All right. Yeah, so, and we made a video about Tor. I'm going to reference it here. Blocking websites. Yeah, ISP uses transparent proxies, which is a layer 4 proxy, right? They make sure they say, hey, we're not going to look at your data. Trust us, right? And if we don't look at your data, here's what we can do. We know where you're going because there's an IP address, there's a port, we know which application you're going. They kind of act like a firewall in that case. And you say, hey, you're not allowed to access these ports because we know that these ports are insecure, whatever. Or, hey, you're going to this website. This is a porn website. We're not allowed it because, like, I don't know, this government decided to, block porn website for some reason. So, yep, block it. So they can do that. The ISP can do that with a proxy, right? Without even looking at your data. And that's easy because they know the IP address. That's plain text right there, right? Except you're using VPN. That's a different story. Right? Used for many application, and we've talked about all of that stuff in this channel. A reverse proxy, which is just a proxy in reverse, right, can be used for load balancing. It's pretty cool stuff. It is used for a service mesh, which is this microservices trend now, right? And it is used as a varnish, like an example of varnish. HTTP accelerator accelerates the HTTP requests, like makes it fast and caching and kind of uh, compresses the scripts and then make them fast. And if there's some JavaScript, looks at it and says, "Hey, you can do better with this JavaScript. Let me rewrite it to do this," and it does all this fancy. And we made a video about Varnish. It's not public yet, so maybe by the time this video goes up, that video will go up. But we made a video about Varnish, and obviously it can act as a firewall, proxy security, right? Because it's the same concept, right? You make a request to the proxy makes a request on your behalf. Or, well, in case of a layer 4 proxy, that's a little different because it plays at a lower level, but that's a different question, but similar, right? Kind of make a request on your behalf, kind of knot things up. Cons, what's bad about this? Application can bypass the proxies, guys. You can just bypass the proxies altogether. Firefox, you can go to Firefox or Chrome and you can choose, I don't want to use any proxy, or I can choose, I want to use the system proxy, I want to use something else. So application can bypass the proxy, and that's a cons, I don't know. So you don't have full control of a proxy. You cannot guarantee that all applications will use the proxy. But proxy are beneficial, right? Especially like there's an application, so that's another benefit I forgot to mention. Proxies like Fiddler, right, can intercept the request and tell you what what request are you making, and this is great for debugging, right? Like Charlie, I think, or Fiddler, they can look at your request. If you're building an application, you can look at the REST request you're making and see what are these requests and all that jazz, right? So it's like, hey, you made a typo here, for example, this request, or this request taking a long time. Not all traffic is routed. HTTP proxy will only forward HTTP traffic. HTTPS proxy will only forward HTTPS traffic, right? This thing, you better know what you're doing when you're using HTTPS or proxy, guys. And SOX proxy works at a lower level, I think layer 4, right? Where you can actually work with lower level applications. Still, there's an option that you can choose or not choose. No encryption by default, right? Proxies don't promise any encryptions, just say, hey, they make a request on your behalf, right? And here's a bullet I added. It's more dangerous than a VPN because, especially when using a HTTPS proxy. Guys, if you're using a public HTTPS proxy, you know what's going on, right? An HTTPS proxy have to look at your data, right, to make a request on your behalf. Otherwise, how does it know, right? So what most proxies do is actually terminate the TLS connection. And what does that mean? That means they serve you their certificate instead of the destination server certificate. And that means they can look at everything you're seeing, right? If you're going to google.com through an HTTPS proxy, you're gonna get a warning, or maybe not necessarily a warning, if the certificate is trusted by your machine, right? They can actually see what you search for. They can see everything because you're sending everything. They terminate the TLS, they look at your data, and then they make a request on your behalf to the final destination. They establish a completely different TLS connection to the google.com or other final destination. So that's dangerous stuff right there, guys. You really need to think about that, right? So terminating TLS, right? And there are other HTTP proxies that actually make a connect request, which is like a tunnel request. These are more secure than others, but always look at your certificate, right? And that's when you go to youtube.com or google.com, look at the certificate. What does it say? Does it say issued for Google, or does it say issued by shady.com, right? Because if it's issued by someone else, that's shady, right? Because they essentially, you are being intercepted and people are looking at your data, okay? And Kazakhstan government, I think there's an article about it, that they forced an ISPs to deploy an HTTPS proxy, and they forced all their citizens, they are forcing, I don't know if they were successful, they are forcing all their citizens to install the certificate by default, so the users will not get prompted that, hey, by the way, you're not really going to the final destination. This is another proxy. No, they just make it silent, right? So if you install this certificate, right, then you're going to google.com, the government can see everything you're searching for, right? Even if it's HTTPS, right? Because they have this terminating TLS, and we talked about TLS termination in this channel, right, guys? Summary: what did we learn? Long video, but hopefully it was worth it. Let me know if you actually benefited from this video in the comment section below, right? How VPN works. We talked about how VPN works. It's a simple technology, but it's very complex and underneath, right? Just make you as a client part of a completely different network, and when you do that, you're essentially can access the private resources of that network, and you can make a request on behalf of that network, so people don't really know who you are, except the VPN does, right? VPN pros and cons. We talked about that, right? There's always pros and cons for this technology. Well, you cannot use a VPN to do a load balancer, but you can use a proxy to do that. VPN can give you access to internal resources and can encrypt your data if you're not using an encrypted channels, right? How proxy works, we talked about that, right? We have a whole playlist of videos about just proxies, and I'm just getting started, guys. There is so much to learn about this tech, right? And people are using this proxies to do a lot of stuff. Okay, proxy pros and cons. We talked about that. There's always nothing is perfect, right? The pros, there's good stuff. We can do load balancing, can do HTTP acceleration, but you gotta be careful, because if you're connecting to a public HTTPS server, make sure that they are not terminating the TLS and they are essentially forwarding your request instead, right? Otherwise, you're in the public essentially. Okay. All right, guys. Hope you enjoyed this video. That's all for me. Hope you enjoyed it. I'm gonna see you on the next one. You guys stay awesome.